Welcome to your first year of electronics engineering. This course will introduce you to the fundamental concepts and principles that form the foundation of electronics and electrical engineering. By the end of this course, you will have a solid understanding of various electronic components, circuits, and systems. Let's dive into what you'll be learning and the prerequisites needed to succeed in this course. In this course, we will cover basic electrical concepts, circuit components, circuit analysis techniques, AC and DC circuits, and signal processing. We will start with basic electrical concepts such as electric charge and current, voltage and resistance, and the fundamental principle known as Ohm's law. Ohm's law is given by the formula V equals I times R, where V is voltage, I is current, and R is resistance. Electric charge is a fundamental property of matter that causes it to experience a force when placed in an electric and magnetic field. Electric current is the flow of electric charge, and it is measured in amperes. Voltage, or potential difference, is the measure of electric potential energy per unit charge. Resistance is the opposition to the flow of current in a circuit. Both voltage and resistance play crucial roles in determining how electric circuits behave. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, with the constant of proportionality being the resistance. The formula is V equals I times R, where V is voltage, I is current, and R is resistance. Next, we will explore various circuit components such as resistors, capacitors, and inductors. We will also cover semiconductor devices like diodes and transistors and understand the basics of operational amplifiers. Resistors, capacitors, and inductors are basic passive components used in circuits. Resistors limit current, capacitors store energy in an electric field, and inductors store energy in a magnetic field. Diodes and transistors are semiconductor devices. Diodes allow current to flow in one direction only, while transistors can amplify or switch electronic signals, making them essential in modern electronics. Operational amplifiers, or op-amps, are versatile components used in various circuits. They can amplify weak signals and are used in applications such as filtering, oscillation, and signal conditioning. We will learn circuit analysis techniques, including analyzing series and parallel circuits, and applying Kirchhoff's voltage law and Kirchhoff's current law. Kirchhoff's voltage law states that the sum of all voltages around a closed loop is zero, and Kirchhoff's current law states that the sum of all currents entering a junction is zero. In a series circuit, the total resistance is the sum of individual resistances. In a parallel circuit, the total resistance is given by the reciprocal of the sum of the reciprocals of individual resistances. Kirchhoff's voltage law states that the sum of all voltages around a closed loop is zero. Kirchhoff's current law states that the sum of all currents entering a junction is zero. These laws are essential for analyzing complex circuits. We will study both direct current, or DC circuits, which are powered by a constant voltage or current source, and alternating current, or AC circuits, which are powered by sources that vary sinusoidally with time. We will also analyze impedance and reactance in AC circuits. Finally, we will cover signal processing, including the differentiation between analog and digital signals, and the basics of signal filtering and modulation techniques used in communication systems. To ensure you are well prepared for this course, it is important to have a basic understanding of mathematics, including algebra, trigonometry, and calculus. You should also be familiar with basic physics concepts, such as mechanics and electromagnetism, and have some computer skills, including basic programming and knowledge of software tools for circuit design and analysis. Consider a simple circuit with a 9-volt battery and a resistor of 3 ohms. Using Ohm's law, we can calculate the current flowing through the circuit. The current I is equal to the voltage V divided by the resistance R, which gives us 3 amperes. In a series circuit, the total resistance is the sum of individual resistances. For example, if you have 3 resistors with values R1, R2, and R3, the total resistance is R1 plus R2 plus R3. In a parallel circuit, The total resistance is given by the reciprocal of the sum of the reciprocals of individual resistances. For an AC circuit with a resistor and an inductor in series, the impedance Z is given by the square root of the sum of the squares of the resistance R and the inductive reactance XL. The inductive reactance XL is given by 2 pi FL, where F is the frequency of the AC source and L is the inductance. By understanding these fundamental concepts and prerequisites, you will be well equipped to tackle the exciting challenges and opportunities in the field of electronics engineering. Let's get started.